Uh, Today, I will to introduce the APAC Opto silicon photonics, our technology for the related application. So outline I will quick to give you the idea about our company, then talk more about our core technology. Then I trying to give the idea for the CPO, the fiber coupling solution. Then we're looking for the partner to do the development together. Then give you the summary today. Okay, so the APAC Opto we founded from the year 1998, so more than 20 years. The optical transceiver shipping to the market, and we are the IPO company in Taiwan. So with the healthy the financial performance to support the long-term business because the optical communication, the generation to generation investment is quite huge. And the third one is the quick talk about our product portfolio. We support a very comprehensive transceiver from the very low data rate to the 800, and right now we are developing 1.6 tera for all kinds of the application, no matter the data center, the switch, or the mobile front home, even though the fiber to the home. Then today, because I will talk more about the silicon photonics related, then we have the technology platform to support this application. So this slide give you the introduction about our technology from the design to the manufacturing as the package and all automation related. Of course, for the optical transceiver design, we need to have a capability from all kinds of the simulation, like the high-speed circuitry, optical system, the thermal and the stress simulation, and of course the validation platform. Then for the material wise, there's so many epoxy be used in the optical transceiver. So we have the know-how how to pick up the right epoxy, how to do the validation, and of course the optics related, no matter the active or the passive components, and high speed the substrate, and of course the oil composition. Then some software, firmware, and seamless compliant the development, and of course for the reliability validation platform. Then for the package wise, we have the internally the TOCAN and utility bonding the capability and high precision the tree on board the package technology. Then for the automation, of course, like the die bond, wire bond, active aligner, the bending, and of course the testing. Then in the left side, I'll give the more idea about our the silicon photonics the technology platform, because we have experience to development the 800 DR8, the V group based silicon photonics the transceiver. Then for the 400 G the DR4, we pick up the edge coupled in the peak. So based on such kind of the transceiver, pluggable transceiver design experience, so our technology platform to support silicon photonics will include in like again for the optical system design, then the precision, the die, all kinds of dice package, then the passive, the FAU attachment to the V group peak, and active or T transmitter side and the receiver side coupling, and of course the index matching epoxy system. And of course, for the CW laser, there's the higher power consumption with the heat. So the good thermal management capability for CW laser. And of course, we also can handle for the remote laser diode with the PM fiber measurement. Then we also have the remote, the CW laser, the optical module to support the CPO application. Okay, then this page, there's some high-level idea about our the CPO or fiber coupling solution, because CPO is very hot in Taiwan right now. So we come out our idea and looking for some partnership. The feature, of course, for a CPO, the most people we talking with are looking for a detachable optical interconnection, and how to have such kind of the mechanical design. The most important is for the very low the coupling loss, Then we design the whole optical system. Then to support, based on if we're using the match the Morpheus diameter as the chart here, our do some simulation, then we can handle the window around the 20 micrometer to test the 2 dB the coupling loss to support for detachable the mechanical design. Then for the peak, we can support the vertical coupling, so you can see it's the pattern, something the structure like a TSMC is a vertical coupling. And in the right bottom side, we can also support edge coupling with the V groove, such kind of the peak. Then for the coupling process, our the system, our idea is to do the passive alignment. And for the tolerance, we need the bonding accuracy to below the 2 micrometer, so we can support the coupling, the beta coupling loss, the beta coupling efficiency, the rotor coupling loss. And for the connector wise, because right now our idea is to come out something like the mini MT or MT like the mechanical structure. But of course, for if needing the more channels, we can discuss with our partner to come out the potential, the architecture. Yeah, so the purpose today, of course, is to looking for a partnership for the JDM. So our partner wishing to pick up the Silicon Photonics, the design company, and also the package company. Okay, so I do the summary here. As our introduction, we have ready to go the Silicon Photonics, the package and the testing capability, and we have the spin record for the Silicon Photonics, the pluggable, the transceiver. And the second thing is the major the target today to looking for the partnership from the PIC or the offset. Then the potential need to discussion the subject, for example, for the PIC. We need to discuss what FD from the waveguide design. Then because our target is to do some passive alignment for our lens, then we need to discuss the bonding pad design on the PIC. Then for the offset as the high level, for example, the simulation, we're looking for the below the 2 micrometer, the post-shift accuracy bonding. I think it should be quite mature in the market, but anyway, if we have a partner, we can to discuss how to work together. Then for our portion, of course, we do the optical system design, the lens FAU solution design, and also the detachable, the mechanical, the solution design. Yeah, then if you have any question, you can ask me or you can contact. I showed my email in the slide. Yeah, it's my presentation today.